briefly about the, I don't know. I don't know if I want to talk about it or not. So I'm going to have Javier put out a poll. And if he doesn't, I just 30 minutes ago asked him to create a poll. If he doesn't, then I'll make the poll. But I wanted to, it's sort of been brought to my attention by a couple of people to talk about the Tuesday before Thanksgiving. And so I believe I'm bad with dates, but I believe that's the 20th, possibly. And so I'm going to have Javier put out a poll in Blackboard for you to be able to vote on yes, you'd like class, no, you don't want class, and possibly maybe a video recording of the lecture. I'm okay. I'm open to all of them. So we'll see what the class says. We want everybody's opinion. Yes?
Is this supposed to be a class day?
Yes.
From what I believe, yes. Yes. I've just had a couple of people approach me. And so, to be fair to everyone, let's at least see what the poll looks like. And so in that poll, my options in my mind are yes, no, video, recording. So we'll see. We'll go from there. Okay? And so that's one topic of discussion. But so look for it in the next week, that poll. Yes?
So just to be clear, it's either yes, do class, or no, and a video recording, not three options.
It's 3 options.
Okay. So
yes.
No, in case there's a no, would that just be that we would just not cover that material, or what?
I'd shift.
Okay.
Because topic 10 is not a real topic. Topic 10 is, so we've done everything. Just a summary. What have we covered in this course? And that's all topic 10 is. So I could push the rest of part 9 to that day. So it's not possible. So yes, no at all, none at all, and then a video recording. Question from afar.
Yeah, I guess you can see.
Could we potentially push the class back and have class on December 4th? I'm going to say no, just not for me, but reading days are an A&M sort of major school schedule thing, which I don't think we can really play with. So I'm sorry, I'm going to say no, because I think we have to stick strict to their schedule. If there's no class, there's no class. It's supposed to be a study day, but neither here nor there. So we'll see. We'll see what everyone says, and we'll talk about it next week, what the poll looked like. The other thing I wanted to talk about was the November 27th lecture class day project presentations. So when I look at the assignment, it is not crystal clear that you are going to be presenting. So I'm wanting that to be known. I don't know how it works, and so we can have a discussion. I don't know have you ever done presentations with your distance people? Yes?
So what Dr. Sheether started last year was just have us make video presentations and email them by a certain date, so that all the class period wasn't taken up us going through all those things, and you could look at them at another time. Now we won't get the benefit of seeing each other present.
Others work, yeah.
Huh?
The interest is to see what others have done.
Yes.
So have you ever done any kind of presentations with the recognition that some of your mates are not here?
That's just how he said it, but in the past he did, so I know there's history of doing that.
The videos, didn't we have videos? I mean, in other cases, we had the videos, but then part of your assignment was to rank other people's videos, or to actually give some feedback or comments, so therefore you're kind of forced to watch it. So it did take up class time, but at the same time, you could watch the videos and see what people were saying. So.
But we have class time. Unless that topic gets pushed.
Maybe that's another poll.
Unless the topic gets pushed.
Yeah.
So, okay.
So,
it's
well, we
still
have
up
8
in the
groups,
air.
7 groups. How many groups do we have?
How many?
There's 8.
There's 8.
So if they each do 10 minutes, that's almost an hour and a half.
Right. But how does that work with your distance partners? That's my only concern. That's my only concern is your distance partners.
They can present on screen. They can put a little camera on.
Yeah, right.
They could participate and be elected.
Yeah, 10 minutes per group means
Yeah.
that you have each person talking for about 1 to 2 minutes.
Yeah.
It's very stressful and nerve-wracking.
I can envision the timing being very stressful and nerve-wracking. So we don't have to make the decision today. I just wanted to put it out there, sort of float. I needed to hear what you've done in the past and how.
What have you done in other classes?
I've never had distance students
Oh,
who were in groups
yeah.
with in-class students. So I've had distance students, and so they did video presentations on, and then everyone would watch them. And I've had in-class students, but I've never had groups made of both. That's my challenge, groups made of both. So
We're just trying to be special.
yeah, but I know it's a good thing. So we don't have to make the, I mean, so a
Going
comment.
back to the class on the day before Thanksgiving.
Yes, the Tuesday.
Can't you do a remote class? Do you present remotely? We can join it.
Yes.
That makes it easier for you that you don't.
I mean, that's the idea of some version of me talking through it, right? So, but we'll see.
Just like you do office hours.
Yes, so I'm open to that too. So we'll see what the poll says. Yes, question. No.
You can't see it.
I can't see it.
They sent it directly. They said, why do they need to present? Could they just submit the project and have you grade it?
So that's going to happen, but the purpose of the presenting is to share with others the time series that you've been, the industry that you've been looking at, and the time series that you were able to play with. I mean, your group has only worked with the in-class examples, and you're one possible time series from your group. So it's just to see what others did and how some are going to be probably sophisticated and some are going to be sort of simple, but it's to see the full spectrum of the possibilities of what came out of the fruits of this class. So it kind of is a great way to wrap up a class to see what others did. But we'll see what happens. I don't know. We'll see what happens. So I'll keep thinking about it. Okay. Alrighty. So those are just the things on the table. And when I already sent it to Javier to put it out there, but he's probably not going to do it till tomorrow. But I'll sort of have him break down the idea of the video, the office hour style, pre-recorded style, that kind of thing. So there'll be some options. Okay. Question?
When are we going to get feedback about the project?
My hope is before tomorrow morning. That's my hope. Before tomorrow morning. All right. So we were asked. The question was about feedback from the project because you want to get moving, and so my hope is before the morning. Hopefully, maybe before midnight. Yes.
I don't know if you discussed this already, but the final exam, will it be an in-class?
No, we have not talked about it, but and I don't want to put it's going to be a take-home, similar to what you saw in the midterm. Don't hold me to that 100%, but I'm 80% there.
Okay.
So, yes. Okay. All right. Okay. All right. So we're going to get moving now. That was sort of, housekeeping. Okay. So now, yeah, I'm on. Today is going to be sort of a how-to. So now you can take a deep breath, I hope. Today's lecture and next week's lecture, take a deep breath and say, okay, you have to think, but you don't have to think as hard as you were thinking all of these weeks that's led up to this, because now you can sort of take a back seat to software. You know enough information about modeling of time series data. You know enough about the assumptions necessary to make it valid. So now you can take a seat back and let the software run for you and see where it takes you. Okay, so the idea in general is I would expect you with your time series, especially in your projects, to go through the analysis in the format that we have, right? Examining it, looking at the ACF and the partial autocorrelation functions and determining if you can come up with a model or not, and maybe doing an ARIMA model group if you couldn't, that kind of thing. To do that. And then after you've run that process, to then go into SAS, Forecast Studio, and see what it believes that the best optimal model is for your data set. So let's take a look. This is sort of, these slides are a how-to to handle the software, to get it to perform and do the things that you'd like it to do. Okay. Questions? All right. And so we're going to go through this. Okay. So in this topic, we're going to learn about SAS Forecast Studio. Hopefully you were able to or have it downloaded when you downloaded the SAS software. I had glitches with mine, but Hopefully you did not. So we're going to explore the use of SAS Forecast Studio as a means to automatically fit time series models to your data. It's going to automatically do it for you. To learn a little bit about what's going on with SAS Forecast Studio, it's a client component of the SAS Forecast Server. The SAS Forecast Server is a large-scale automatic forecasting solution that enables organizations to produce huge quantities of high-quality forecasts quickly and automatically. SAS high-performance forecasting automatically selects the appropriate model for each item being forecast based on your user-defined criteria. What it's able to do is it's able to do all three of the forecasting steps. That means it's able to do model selection, it's able to do parameter estimation, and it's able to do forecast generation. It can do all three of those steps for you. It can do just two of them. That means it could do the estimation of the parameters and forecasting, or it could just do forecasting for you. Okay, so you can get into SAS Forecast Studio at any step in the process, even at the very beginning. Okay. And so the version that you should have at your disposal is SAS Forecast Studio for desktop product version 14.3. And what it's going to do is automatically fit time series models, which can at the same time, this is the great part about it, detect and allow for outliers and level shifts, and determine which model or models optimize the chosen fit criteria. So let's take a look at some data. 1,000 points from an unknown ARIMA PDQ process. Okay, so this is what this time series looks like. Okay, hopefully what you'll see, you should be very comfortable or familiar with this type of time series plot where you see an increasing trend, right, in the time series plot, and the autocorrelation function doesn't decay. So this information leads you to the idea of, I probably need to difference this data. Okay, so if you difference the data in JMP, I did a non-seasonal difference on this data. What are we able to conclude? Okay, after a non-seasonal difference, any ideas for the model based on the autocorrelation function, partial autocorrelation function? I'd say I wouldn't be super strong saying yes, it is. My feeling is it's probably an ARMA of some kind. Exactly what type of ARMA, I'm not sure, right? Or be more specific, an ARIMA, because we already differenced it. But what type, not for sure. But what are the significant lags in the autocorrelation function? We have significant lags up to 4. In the partial autocorrelation function, we have significant lags up to about 5. And so using JMP and its powerful tool, the ARIMA model group, I looked at autoregressive orders from 0 to 5, differencing 0 to 1, and the moving average orders 0 to 5. Okay, so basically through 5 on both the P's and the Q's. When you run this ARIMA model group, you end up with 72 possible combinations. And of those 72 possible combinations, the ARIMA 111 has the smallest SBC. Okay, so the ARIMA 111 has the smallest SBC, so let's fit it to the data, an ARIMA 111. Okay. This should feel familiar, nothing that we haven't done before. All right. So when we fit an ARIMA 111 to this 1,000 points, what do we see? What we see is that we end up with a valid model. If you take a look at the Leon-Box Q statistics, all of them are non-significant, leading us to the knowledge that it appears that our residuals are white noise. If you examine the residual plot, you can see that it appears that the mean is equal to 0 and that the variance appears to be fairly constant. Okay, might be a few outliers, but fairly constant. So, ARIMA 111 is a valid model. So at this point, let's learn something new. And learning something new is let's see if we can get it to automatically, SAS Forecast Studio to automatically fit a model to our data. And let's see what it comes up with. Okay. So to begin the process of using SAS Forecast Studio, all you have to do is go down to your Start button, All Programs, SAS, and then you should see SAS Forecast Studio. Okay, and then you might see after that SAS Forecast Studio 14.3. You don't see it?
I see
Sean?
it, but it's an error. I want to know if it won't.
Mine had an error too.
Mine's 14.2.
It says it's not connected to the
Mine
server.
says something, so mine had an error too. So I just assumed I had a bad download of it. That's what I assumed, so I was gonna re-download it with a stronger. So I had an error, I had an issue with opening the new version, but I was blaming mine on my poor Wi-Fi speed with the downloading process. So I was gonna try at a university on Thursday to re-download it. Okay, but hopefully someone in your group will have access to SAS Forecast Studio, that it works properly. So 14.3 came out September of last year. And so some of you, it might be still working with 14.2. The changes are minimal. So if you have it working with 14.2, perfectly fine. But once you get it to open, okay, once you get it to open on your laptop or your computer, what you're going to do is you're going to go to New. And what you're doing here is creating a project, creating the work you're going to do. So you're going to click on New. Once you click on New, then you will type in here a project name. Okay? So you enter a name for your project, and then literally you click Next. And what we're going to start doing in this SAS Forecast Studio is we're going to go through approximately 8 steps. Some of them we kind of skip over because they're pieces we don't have to adjust, but we're going to go through these 8 steps. First step is to create a project. Okay, second step is to get your data. And so there are many ways to probably get your data if you could be using it in work, but most people, easiest way to get your data is to have your data sitting in your My SAS files. Mine is 9.4, probably yours is too. Have your data sitting in this folder. If your data is sitting in the Documents My SAS Files 9.4 folder, then it will be sitting in SAS User. Okay, so this is a folder that was created when SAS was downloaded onto your system. Okay, so if you put the data set there, then you'll be able to access it in the folder, the file SAS User here. So once you open your SAS User drawer, you'll see your data sets, whichever ones you have sitting there. And so this one was called ARIMA PDQ, right? Because we're trying to figure out what model to fit to this 1,000 objects time series. So we click on Next. Once you click on Next, select the SAS data set you want, then click on Next. And then we're at step 3. And here you can skip through this one, literally click on Next, because we don't have any classification variables for our data set. Now we're getting to the pieces where we do have information. So in step 4, what you have to tell it in step 4 is, question, Sean.
Yeah, I think the majority of people can't make it work, but I think that 1 or 2 people can. So perhaps if the people who can make it work could share with us what they did, we can get it going.
Share what they did to make it work? I just assumed it was in the download process, but who's able to, let me see what the question is also in the background.
I can't see it. They said, what data are you using?
Oh, I don't have it posted. It's just a simulated data set of an ARIMA 111.
Which version are you trying to open? I tried to open 14.3. Is that the one you opened?
I've only got 1 version.
I only have 1 version also.
I've got 14.2. I don't have
Yeah, mine is
14.3.
You've got 40.
But I don't have that data set. I have 2 other data sets.
So 14.3.
I didn't post this. It's just a simulated data set.
Yeah, I'm just going to play with the one I got.
Play with the one you have. Or you could jump ahead and play with transactions from Main Turnpike, because that's where we're going.
Is that somebody download?
Say it.
Do I need to download that from your?
Yeah, it's in the data sets.
What is?
Yeah,
For me, I just
under case study 3.
but it just
So
took a
it's
while to
up
open.
high. So are we coming up with a solution, Vanessa? I'm sorry, I was in another conversation.
I clicked it and opened it, and then it just took a while for it to open, but then it eventually, it actually opened like 3 times because I had done it,
Mine gives an error, something about default. I don't remember what it said, but it was an error more than anything else.
But I was using 14.3, I don't know.
And you're using 14.3.
How many people can't get it?
How many people don't have access to SAS Forecast Studio? In here.
There's a student online that has 14.2. There's 2 that can't get on 14.2.
I can't open mine. One.
How would we know?
Say it again.
14.2 it works.
How would we know if we have access to it?
Oh, so you go to the start menu, all programs, click on SAS, and when you click on SAS, you should see SAS Forecast Studio. And so when I did that, I didn't see SAS Forecast Studio. So then I went back to the download stuff they sent us and opened it up and then clicked on SAS Forecast Studio because I guess I hadn't added that part. But then so it's on my system, but then when I try to open it, I get a glitch. But so who does have it? I know not everybody's playing on their computers with it. A decent number. Okay. So we all know that for those of us who don't have it, between now and the next 3 weeks, we'll solve the problem with Javier / Myra to see if we can work it out. Okay. There's that's what Myra said. There was some installation but I'm not in that group. So what is the name of the class or section where that folder is? It's called Community Analytics and Software Help Documents. So
and then there's Enterprise Guide Fix. I downloaded
the whole thing. Yes. So Community Data Analytics. This is on the eCampus website.
Yeah, but it's like 30 gigs. So it's like a 30 gig file.
It's like a 30-day file?
No, 30 gigabytes. Yeah.
Oh, 30 gigabytes, yes, and that's what I was, my Wi-Fi speed was slow. Okay, all right, so this is just the how-to, what you're actually gonna end up doing with your group, if someone in your group has it, / if not with your group, a week from now. We're gonna still be in SAS Forecast Studio, so you're not gonna be, I promise, behind. Still working with your laptops to get them to, I think Myra has a heads up a little when I contacted her today to say mine wasn't working. I kind of warned her. I was worried it wasn't going to work for some students also if I ran into a glitch. So I think she has a little heads up, but now she'll get a bigger one. So we were at step 4, I believe, of the process. And in step 4, what you have to do is you need to tell SAS what your time ID variable is going to be. And so for this data set, it was date. This was daily data. And so you just click on date and you tell it your interval. And then click on next. Okay. And then in step 5, here you're telling it your dependent variable. So you select the Y variable. In our most cases, when I do the simulated data, it's YT. And you choose it dependent for its role. So you click on the role and go down to dependent, and then you click on next. Then in step 6, there's nothing to do. You can scroll through that. Okay. Step 6 deals with things like if you had missing data, ways of handling that. Then in step 7, we are going to do some little finessing to our project. So here we're going to click on Change Other Forecast Settings. Once you click on Change Other Forecast Settings, you're going to click on Model Selection under those forecast settings. And under those, under Model Selections, what you're going to be able to do then is choose what your criteria is for model selection. And so here in this analysis, I clicked on Schwartz-Bayesian Information Criteria as my go-to. All right. The default is mean absolute percent error. So here using Schwartz or SBC, click OK, and then you're at the last, or on step 7, and you just click Finish at this point. Okay. And so once you've finished the steps in SAS Forecast Studio, what you're going to get first is a forecast summary, okay? And in that forecast summary, there are going to be at least 4 boxes. It will have this information for every model that you worked with, if you use more than one type of model. So the first box that you'll see in your forecast summary is just a graph of the distribution of the specified statistic of fit. So this is just a histogram or box plot of your SBC, the distribution of the Schwartz-Bayesian criterion. It's one box. And then the second graphical display shows how each model type fits the series. So here it selected an ARMA model, okay, to fit this series. And then the third box is a graph of the model type. This graph is going to show whether the model included a dependent transformation, a seasonal component, a trend component, possible inputs, events, and outliers. So here we're going to use a trend model. And then the last graphical display, which is a table of the number of errors that it might have encountered. Okay, and here it didn't encounter any. So after that, what you're going to want to click on is the forecast summary, forecasting view. So clicking on forecasting view here, what you're going to get, it's going to display the forecast plot and the data table for the time series. Okay, so this is towards the end of the time series. These are some of the forecasts. After you've looked at the forecasting view, you can then click on modeling view, which is next to it. So forecasting view is on the left, modeling view is right next to it. So if you click on modeling view, this is what you end up with. From the modeling view, it enables you to view the plots and the tables for the selected model. So we're looking at this ARIMA model, and we're able to see what the errors look like here. This is probably the plot you're most familiar with from SAS. So the white noise probability plot for the errors of this ARIMA model, and they appear to be white noise. The errors appear to be white noise. That's the take-home message. Still in this modeling view, if you click on tables, so tables is right here. If you click on tables, and then once tables drops down, click on parameter estimates, you'll end up with the table for your parameter estimates. And what you can see here, so if you click on table and then it'll drop down, you'll click on parameter estimates, you'll get a table of the parameter estimates. And what you can see here is we have coefficients for the moving average component, for the autoregressive component, and that they are significant. Okay, so we're able to see the parameter estimates for the model. You can save or copy those parameter estimates if you're interested. So to do that, all you have to do is right-click anywhere in the table, and this works for any table. Right-click anywhere in the table, and then select copy, and then image, and then you'll be able to copy it into any document that you like. So to move from SAS Studio Forecast to your PDF or your Word document, it's very, very easy. That table, when you copy it, would look something like this. Right? Okay. So also, parameter estimates, under that tables, parameter estimates, you can also look at the forecast. Right? So instead of clicking on parameter estimates, click on forecast values. When you click on the forecast values, what you'll get is a table that looks like this. It's very small, but here's our forecast values. Okay. And then, I know if you were wondering how do we did 12 forecasts back on slide 18, back in step 7. Let me go back to slide 18 in my notes. Back in slide 18, step number 7 of the new project, the periods was automatically filled for you as 12. Okay, so it forecasted ahead 12 time points. It's hard to see, but I'll show it again later on. but this little button here becomes very useful. It's a magnifying glass kind of over a graphical display. So it's this last button right here on the right above the model statement. This little button here will provide you with the diagnostics for your model, but we'll come back to it. I just wanted to show you where it was. So when you're in the modeling view, as we are still at this point, if you double click on the model that was created, so this generated ARIMA model, if you double click on it, generated ARIMA model, what you'll end up with are the methods kind of behind the modeling and the information that you've been kind of like, you saw the parameter estimates, but you know, you wanted to be sure exactly what was the model that it's using, what model did it come up with. If you double click on the model name that it generated, it'll provide you with some of the background information. So what you'll see here in this image is you're able to see what method it used for the estimating of the parameters. And so the default method in SAS Studio Forecast is conditional least squares. So the method here was conditional least squares CLS. Other pieces of information that you might want to walk away with are to be sure about what your PDQs are, seasonal and non-seasonal. So you're able to see here that we did a differencing, and we have one for lag for our P parameter and one lag for our Q parameter. Okay, so you could also see that in the details above if you didn't look here. So it gives you more concrete, something to touch, to connect with if you're trying to see exactly what was the model that it came up with. You're able to view it there. As I said, that little magnifier above the graph, if you click on the rightmost icon above model, that little magnifier with a graphical display behind it, what you're going to get are you're going to be able to view the diagnostics connected with the model. And so what you'll see, what will pop up first is what's the best model for your time series. And so here you're able to see the best model for the time series was an ARIMA model, and it included the constant, and the PDQs were 1, and there was no seasonal parts. It uses SBC for the model criteria with a result of 68.2955. And I know one of the questions was exponential smoothing model specification. So the default models that SAS Forecast Studio uses to create a fit for your model is both an ARIMA and an exponential smoother. So those are the defaults that it automatically goes to. Make sure I set everything. Okay. Alrighty. Okay, so from this point, to further examine this model that it came up with, you can click on, so hard to see, the 5th icon from the left above the model. And what that will do is create a copy of the selected model. So that image is very, very small. If you look at, because I can't even describe what it looks like. That's why I didn't have a description for it. But it's kind of like the SAS symbol to me. That's what when I think of the SAS program, it's that little SAS symbol. So it's the 5th icon from the left. And what that's going to do is create a copy of your selected model. Okay. And in this same screen, you can manipulate the model, meaning you can change the estimation process. So instead of using the conditional least squares, you can change it to do what we've done the majority of the time in SAS, is maximum likelihood, okay, if you desired. So you could go into the estimation and change the method if you wanted to. All right. So that's a little bit about SAS Forecast Studio. Moving on to another part of SAS Forecast Studio that you will probably find useful is this idea of holdout samples. Okay, so if a holdout sample is specified, the model is selected based on the goodness of fit statistic in the holdout region, sort of out of sample fit. And if a holdout sample was specified, the model parameters are estimated using the full range of data, including the holdout sample. So in other words, all that means is the parameters are estimated using all of the data. Okay, so the parameters are going to be estimated using all the data, and then the model is going to be selected based on the criteria in the holdout region, if you have a holdout sample. Okay, so parameters are estimated using all the data, and the model is selected from the goodness of fit statistic on the holdout region. Okay.
That actually lends itself good to a more generalized question. In the examples, sometimes we have a year and a half, or sometimes we have just 2 days. How do you recommend going about selecting a holdout sample for a time series problem? Like, how big should it be?
It depends on how big your data is.
Okay.
Depends on how big your data is. Because the holdout sample is going to come from the most recent data. That's what it's going to hold out. I'm going to say there's not I can't tell you a rule of thumb, but I'd say hang around 25%. Hang around on the high end, hang around 25%. So, okay. But if you go, there's not a rule of thumb. There's not. Everyone's not going to agree. But the more data you have, the larger your. So there is a limit. So that's one thing about. Let me just say there is an issue with SAS Forecast Studio. SAS Forecast Studio desktop version, which is what we should have, has a limit of 1,000. Has a limit of 1,000 observations. No, for your time series.
Ooh, kind of small.
I mean, I don't quote me, but I think quote me. Yeah, I think it's 1,000. It's small. So that's a limitation. But this is just to give us an idea of, so you could use your most recent 1,000 observations if you wanted to get an idea of what your, an automatic fit to your data. So that is one of the limitations.
So the functionality is the same with SAS and the SAS forecast?
Functionality, meaning?
The results that we're seeing, they're exactly the same. So if you have a large sample data, you could just use the normal SAS?
Yes and no. So say you had a large, that's not going to be the truth. If you have a large time series and you're working on it in SAS, and you have 5,000 observations, the response, the answer you get from SAS Forecast Studio is not going to match identically, because you're only going to be using 1,000 of that if you have the desktop version. If you have the bigger corporate version, it can handle 5,000, but if just the desktop version, it can't handle more than 1,000. So no, they're not going to match perfectly.
It's the same method.
But it's the same methods. The same methods, yes, but you just have to make sure you specify the same modeling estimation technique. And then, yes, moving forward, yes, same methods. So what's the benefit of this? But it's doing it all at once. So JMP, what do we have to do? We do JMP. We come up with model ideas, then we go into SAS to deal with the outliers, right? So we bounce between the two. JMP is user-friendly to get us going, but when it comes to dealing with the outliers, we got to go visit SAS, right? So you're going to see in SAS Forecast Studio, it can do it all at one time. And it's doing it without you interpreting it. If you think about the SAS programming we do, we programmed it. We told it what model to fit to the data, right? Or what model to check, that kind of thing. Versus in SAS Forecast Studio, it's like put your time series in and sit back. And it's going to give you an answer. I mean, it's great to compare to what you got through your process. I mean, so. And another model to investigate, because many times you might come up with different models, possibly.
It calculates parameters based on all the data.
Yes, all the data that's in SAS Forecast Studio, including the holdout. Well, you have the data exists. So yes, you want the best parameter estimate possible. And you don't want to leave out the data. More information only makes your estimation better. Okay. Where are we going? Alrighty. I think I'm just reiterating what I said here. So this is what we saw. Oh, question in the back. Maybe lots of questions. For some reason, I do not see the data after I'm putting the data. It is not anyone run. Okay, so it says for some reason I do not see the data after creating the project and putting the data in Documents, My SAS Files 9.4. It is not displayed under SAS User. Anyone run into this problem? Anybody put some data in their My SAS User folder?
Is it in the SAS format?
Oh, thank you. I didn't think of that.
Yeah,
I didn't think of that.
term by it's in jump and not SAS.
Yeah, so Rita, make sure it's a SAS data set. Make sure the extension is the SAS 7B stuff, yeah. Okay, so make sure it's a SAS data set extension.
I ran into that too.
Okay.
But I was trying to open it, I was in their project prompt window.
Yes.
And to get out of that, get back into the forecast.
Oh.
And then start over the process again.
So what I think I heard your colleague say is kind of close out of SAS Forecast Studio, put the data in the correct folder, then go back into SAS Forecast Studio because maybe it's not able to update itself quick enough. Okay, so I hope that answers your question, Rita. Try those two things. Make sure it's a SAS data set, and then possibly close out a SAS Forecast. Make sure it's in that folder, and then open SAS Forecast Studio again. Okay, alrighty. And so these were the results of our ARIMA PDQ when we tried to automatically fit a model using SAS Forecast Studio. It gave us an ARIMA 111 with the Schwartz-Bayesian criterion of 68.2955. Okay, so let's revisit this world in a different way, right? Let's revisit it now that we know a little bit about holdout samples, okay? So just trying to show you some of the possibilities in the world of SAS Forecast Studio. So here, it's going to be a model based on a 25% holdout, and the criteria is going to be the MAPE, okay, the mean absolute percent error. So the model with the smallest mean absolute percent error is the best performing model, right? So the first few steps in creating a project are going to be exactly the same, where you enter the name, you go and find your data set, and specify the time ID variable, okay? So the first 4 steps are similar, identical. Then similarly, step 5, you recognize your variable, your dependent variable. Make sure you put it there as the variable and make sure the role is dependent. And then this is where the holdout sample opportunity arises. It arises when you click on forecasting settings, model selection, and in model selection you want to click on the use holdout sample for model selection, and here the 25% I filled in. It's 1,000, so 250, or you can do maximum percentage and it'll populate itself. Okay, so this is where the holdout sample is recognized or created in SAS Forecast Studio. So then, clicking through the rest of the steps, which are identical, we end up at our forecast summary. Okay, and so here our forecast summary is similar for pictures. Here, though, instead of an SBC distribution, it's the distribution for the MAPE. And here, the model family that was focused on selected was an exponential smoother. Okay, and none of these models types matter here, and there were no failures. Okay, so it chose an exponential smoother to be the best model when we're looking at the criteria MAPE with a 25% holdout. Okay. What we're seeing here is you're able to look at the modeling view. We're in the modeling view of this generated exponential smoother. And what we're able to see is that the residuals don't appear, as you would expect, to be white noise. Okay. So I question the validity of the model. Looking though at the results, what it's telling us and why it selected it was that the exponential smoothing model produced a lower value of MAPE compared to the ARIMA model. Okay, so the MAPE for the ARIMA model was 14.56, and for the exponential smoother was 10.5. Okay, so it was recommending, if you're using the model criteria of MAPE, then it was recommending an exponential smoother. Okay. And then you can, similarly as we did before, you can have it show you the forecast for your model. So these are the forecasts for the exponential smoother here to the right, compared to the forecast that we had with our ARIMA 111. Okay. Just showing you the different capabilities of SAS Forecast Studio. Okay, alrighty. And so, maybe some time to play around. So where we're going is we're going to look at the transactions from the main Turnpike data. Yes, Genty? Okay.
But I downloaded from the jump drives that they gave us, not the download.
Oh,
I had issues with that.
gotcha. So if you're having issues, one possibility is if you have a USB that was given to you at the beginning of the semester here at A&M, then try to possibly download it from there. But some have had success from the community file, and some have had success with the USB. So we're going to take a little break. When we come back from the break, we're going to revisit SAS Studio Forecast, looking at the main Turnpike data, and moving on to this world of dealing with outliers in SAS Forecast Studio automatically. And then after that, I didn't do a plan of action for today because it was just SAS Forecast Studio. After that, we'll take a look at some New York Taxi fare data and try to do it ourselves for those in our groups who have access to SAS Forecast Studio. Yes, Genty?
Sorry, when SAS forecast isolates dependent and independent variable report only.
Dependent.
What about
Right now, we're just dealing with dependent variables, right? So our time series is the dependent variable, like the y. Okay? All right. Any questions? Okay, so let's take a 10-minute break, and we will come back and visit main Turnpike transactions.
Okay.
So now we're going to turn, can you hear me okay, Mason?
Yes, ma'am.
Okay. We're going to turn to old data we've looked at before, main Turnpike, and we're going to specifically look at the monthly transactions from January 2007 to December 2016 with the hope of predicting results for 2017, and can be found at the website here. Okay. All right, so we've seen it before. This is what the data looks like. So these are the transactions. And so what you see in this time series plot, hopefully, is strong seasonality. That's evident in the data. How many periods do there appear to be in a season, right? How many periods? Possibly, probably 12, right? A year. Okay, so if we look at a seasonal difference of this data, that's where I started. Okay, so if we begin by examining the seasonally difference data, which is here in the right-hand corner, we can see that the seasonally difference data is definitely not stationary. The mean does not appear to be constant. What else is there to say? Okay. So are we okay with this idea? We looked at the seasonally difference. So we're going to take it up a notch. The mean's not constant. We're going to do two differences, right? A seasonal difference and a non-seasonal difference. So when you do a seasonal difference and a non-seasonal difference, this is what our time series looks like. And when you examine the autocorrelation function and partial autocorrelation functions of the non-seasonal and seasonally difference data. It does appear to be a little more stationary. Not clear in these autocorrelation function, partial autocorrelation function, exactly what the model should be. More than likely, you know, my mind is saying it's some version of an ARMA or an ARIMA to be more specific, but what exactly, don't know, right? We see some seasonality still present. We see some significant lags at around 12 when it comes to the autocorrelation function, around 13 for the partial. So there appears to be seasonal parameters that need to be estimated as well as non-seasonal. So here I did an ARIMA model group, right? Investigate that from 0 to 4 for the P and Q for the non-seasonal part. And then for the seasonal components, looked at P's and Q's from 0 to 1. Okay. And so moving on to the results at 200 models. What we're able to see are that the two best models based on SBC appear to be a seasonal ARIMA that is 210, 011, 12. The second best based on SBC was a 011, 011, 12. Okay, so we're going to run and entertain the first model, the one with the lowest SBC. So when you fit that seasonal ARIMA to this main turnpike transaction data, this is what you end up with. And so what we are able to see are that the residuals do appear to be white noise. All of the Legendre-Box Q statistics are not significant. It appears to have a fairly constant mean of 0. So it does appear that this ARIMA 210, 011, 12 appears to be a valid model. Thing to note, we talked about it, I believe, last time, is we have two differences. We have the differences and the non-seasonal difference and the seasonal difference applied to this data. So the intercept, we would expect it to not be statistically significant. We're going to rerun the model, not including the intercept. Okay. So rerunning the model, not including the intercept, similar results. The residuals appear to be white noise based on the Legendre-Box Q statistics and the image. The parameter estimates are significant. And so what else do I want to say here? That's about it. So we still have a valid model, the one without the intercept. And so now that we have fit a model to our main turnpike data, let's look and check for additive outliers and level shifts using SAS. So when you check for additive outliers and level shifts using SAS, fitting this model to the main turnpike transactions, what you see is that there appear to be two additive outliers, 62 and 12, and a level shift at 99. Okay. Going a little deeper and examining the model parameter estimates. All of the model parameter estimates are significant. The residuals appear to be white noise. We're not going to reject the null hypothesis of white noise. And when we iteratively looked for further outliers, we did not detect any others. Okay. So here, this ARIMA 210, 011, 12 with two additive outliers and one level shift appears to be a valid and parsimonious model. Okay. Why did I backtrack? Okay. This is the SAS code for doing that. Okay. For creating that fitted model and allowing for the two additive outliers and one level shift. And so let's go into SAS Forecast Studio and create a project. So open SAS Forecast Studio, click on New. When you click on New, it should take you to your folder. It should take you to the naming of your project, so we're going to call it the Main Turnpike Transactions. Click on Next. Then you go and grab your data. Okay, so grab the Main Turnpike data. And I believe in Blackboard I have both, I think I have the SAS data set of it sitting there, I believe. All right, and so click on that for step 2. Then step 3, there are no by variables, no classification variables, so just click on Next. Then step 4 is collecting your time ID variable. So for the Main Turnpike data, time is the name of the variable, and the data is monthly. And then click on Next. Okay, and then picking your dependent variable. So here, our dependent variable is transactions. Okay, and it plays the role of dependent. And then click on Next for step 6, which, as I said, deals with missing values, ways of handling them. And then on step 7, we're going to do change other forecasting settings. So click on change other forecasting settings, and then we'll do diagnostics. Okay, so in the diagnostics, this is where you're allowed to search for outliers. So under diagnostics, you would click on detect outliers and fill in the rules that you would like, the settings you would like. So here I use 6, detect 6 outliers with a significance level 0.05. Those are the diagnostics. And then the second thing you would select in the same forecasting settings window is your model selection criteria. Okay, so after clicking and handling the outliers under diagnostics, go to model selection and choose Schwartz-Bayesian information criteria as your selection criteria for your model. And then the last is finish. And so once you've created your project in SAS Forecast Studio, you will end up with your forecast summary. And so the forecast summary gives you the distribution of your criteria. Here was SBC. The second one gives you what model type family it recommended or used, and that was an ARMA. And in that ARMA, it had components that were seasonal, had trend, and outliers were present. There were no failures when it did the fitting. Okay. So after the forecast summary window, typically you should click on forecasting view, then modeling view to see what the fit looks like. So here the forecasting view gives you an image. You are able to see the series and the forecasts that were created. It's also giving you a table of your data and the forecast.
Wow.
Looks like it mirrored the last cycle.
It's very close, yes. It's a good thing, right? All right. And then after doing the forecasting view, as I said, click on the modeling view. In the modeling view, you're able to see some of the diagnostics or some of the assumptions behind the model. And so here you're able to see that the errors appear to be white noise. I have a traditional to go to our normal white noise probability plot from SAS. And so it appears that the errors are white noise. Okay. And then you can click on that little magnifier glass above the graph here, the magnifier. When you click on that, you'll get the diagnostics for your model. So it's telling you what the criteria and what the PDQs are for your model. So here it shows an ARIMA 210-01112 is what it shows to fit to the model. Okay. That should sound familiar. That was what we picked as our best SBC when we were doing it with the ARIMA model group. Okay. To get all of the parameter estimates in one table Under modeling view, you would just click on tables. So under the modeling view, click on tables. Down here, drop down parameter estimates, and then you get the parameter estimates for your moving average and autoregressive parameters and your outliers. Okay. Oh, have we talked about the outliers yet? So no. So here we're able to see what outliers were detected, and so here the outliers were detected if it's easier to see it if you double click or right click on the table of the parameter estimates, copy an image, then it'll blow it up for us. Right? You're able to copy it, and this is the table for those parameter estimates, just able to see it a little bit more blown up scale. And so what it was able to do here is it estimated the parameter estimates for the moving average and the autoregressive components, and then it found two additive outliers. Okay, let me backtrack 1 second. Okay, and so here it found two additive outliers. And to be more specific, those additive outliers, those are the components, don't help you too much, are at observation 98 and observation 62. So I think you can see that here. I placed them here. So those two additive outliers that it located were at observation 98 and 62, and you can see them barely. You can see them displayed in the plot. Okay. All right. So what was the difference, right? Well, why do we get different results? Similar results, but different results. Seeing them side by side, right? These are a comparison of the two models. All right. So the first table is from SAS Forecast Studio. The estimation technique that was used to fit this model was conditional least squares. The previous estimation technique that was used when we were just working in SAS alone was maximum likelihood estimation. And let me add to that, I did a little bit of there's a difference in the outlier detection, right? I did possibility of searching for 10, and my significance was smaller in this group. I think it was 0.005. Here, I think we went out only 6, and it was just 0.05. But same idea, just wanted to show the differences between the two. Okay, so previously we examined the main turnpike transaction with this maximum likelihood estimation. Both techniques, whether in SAS or in SAS Forecast Studio, whether using maximum likelihood estimation or conditional least squares estimation, came up with the same model. Okay, they both came up with an ARIMA 210-01112. Okay, so they came up with the same model. We have differences in outlier detection, but there were different settings on those outlier detections. Also, you can look at the estimates, and there is a slight difference between the parameter estimates for the moving average and autoregressive components, but they are fairly close. Conditional least squares versus maximum likelihood estimation. When your errors, but you'll have to look at them, when your errors are normally distributed, what you expect to see with conditional least squares and maximum likelihood are very, very similar parameter estimates. That's just the idea. Why does one use one over the other? Typically, for conditional least squares, the algorithms that the software is using are a little more simple, a little easier to do. The maximum likelihood estimation techniques usually take numerical optimization, and so a little more sophisticated, sometimes harder to get to, sometimes doesn't always work. But most people in the world of data analytics, when it comes to estimation, tend towards maximum likelihood if you're able to do it. Okay? But it's not always mathematically possible. Okay? So we were still talking about the conditional least squares model that we just ran with the two additive outliers. So if you double click on the name of your model, which happened to be generated ARIMA model, LEAF0, you can see some of the details of that model, specifically the PDQs, and it shows you the idea of the two additive outliers that it located. If you scroll down further, it'll tell you the estimation technique here. Okay, so that's just to investigate it further. And so we're almost there. And so double clicking, we did it before on that fifth icon. It kind of looks like a weird triangle, 3D triangle from the left above the word model. What it's going to do is create a copy of that selected model. Okay, so all of this is going to be pre-populated. And from there, you would want to, though, click on Outlier Variables. Okay. And once you click on Outlier Variables, you say OK. And what you're going to then examine, you can look at the tables and select the forecast values. That's going to create a table for you of the forecasted values using that model, ARIMA 210011112, with the two additive outliers. So creates the forecast table for us of the next 12 values. And then the last two slides show you a comparison of those forecasts for the model from the SAS Forecast Studio, which was based on conditional least squares, next to the actual next to the transactions, and next to, in blue, the forecast based when you use maximum likelihood estimation. Okay, so as you can see, they're fairly close. You can see more clearly, looking at it sort of in its opposite on the other side of the coin, looking at a comparison of the errors between the conditional least squares technique, which is in red, compared to the maximum likelihood technique, which is in blue. Okay, but let's see, they work fairly. The forecast and the errors are the forecasts are very similar, and the errors are fairly close, positives. There's some distance, but not much. Okay, are there any questions? All right. So where we're going to go at this point is Mason was making breakout rooms. So there is a data set from the New York Taxi Fair data, if it's sitting somewhere over here, in here. And so what I'd like for you to do, where is it? I'm sorry. It is under data. The data is, but the exercise is under assignments. So it's under exercise. It is not a homework assignment. It is just a class exercise. And so it's here at the bottom, topic 8, part 1 exercise. Okay, and so it's time to play with SAS Forecast Studio. Hopefully someone in your group has access to a version of it. And so here the goal is to develop a time series model for the fare box per day for New York City taxis using data from January 2011 to June 2017 in order to predict the results for July, August, and September 2017. You want to make sure you allow for potential outliers and level shifts, and then the SAS data set can be found in where all the other data is. Question?
So my SAS files 9.4, that's where you put the data, so it'll show up in SAS user, because that's
Yeah.
where it's working. So is there a way to figure out where SAS user is actually pointing to?
Documents, my SAS files.
That's where it is.
But my SAS files, I put it in there and it's not showing up here. So
Yeah.
I'm wondering.
Similar to what the
It's got to
distance.
be. I just did this a minute ago.
We're having a question about getting the data into that SAS user folder or
Right.
file.
I just put it in 9.4 and it showed up.
Okay, well, I don't know if it's because I had two different versions of SAS because I and so I don't know how to figure out what path it is actually.
Gotcha. You have two versions on your one laptop.
Yeah, because
I hear a distance student. Are you able to help us?
Yes, so Dr. Moon, can you hear me?
We can hear you.
For the student who asked how to find where the folder's located,
And let me tell you the issue. She has two versions of Forecast Studio on her laptop, so she can't tell the exact location of SAS user.
okay, never mind then. I was gonna suggest there's a procedure to determine where certain folders are within SAS, but
Okay, well, what's the procedure? I mean, something.
no, I don't know the procedure I was gonna say, but it sounds like what she has is not gonna be fixed by what I was gonna say.
Gotcha.
Sorry.
Okay, we can delve a little deeper during the breakout. In the topic folder, I have the user guide for SAS Forecast Studio. It is version 14.3 is the user guide, but we can go out on the web and find the user guide 14.2. And so during the breakout, we'll see if we can, I'll search through it and see if they can guide me to where to find that data, or another way to, somewhere else to put it if worst case. So at this point, I'd like you all to go to your breakout sessions, tackle playing with SAS Forecast Studio, and see if you can manipulate it and play with it and get it to work, at least one version of it in your group, so that your group would at least have access to one of them, because I would hope that some of you all would apply it to your project data and see what you get. So you would hope that one person in the group has access. And yes, a question. In the lecture, can you load it up? I'll make sure it's there. She's a student saying they couldn't see the data. So I thought I put it in syllabus and important information data. Maybe I need to move that folder. Let's see if it's really there. So I believed it was here, but maybe this is not the SAS version. Let me see what version. It's a jump version. Okay. Alrighty. I do have a jump version, not a SAS version. I'll put a SAS version up there. Oh, I'm sorry. I was looking at completely the wrong thing. I was looking at Main Turnpike. Here is at the very bottom is the New York City taxi fare. I lost the question. I did not see the main. Oh, I'll put the main Turnpike SAS file in there.
Okay.
That's not there. I'll do that now.
Yeah, okay.
And then there's an error on
Let's go find when we do
eCampus
it.
with the slides for topic 8, part 1.
Yeah.
PDF document failed to load. I hear you, Shima. No, you don't have to. I will be here, so if you need assistance, but you feel comfortable playing in SAS Forecast, then you can keep moving. But we will be there again next week, so hopefully many of our issues with the software will be resolved. And it's working. So I just need a better Wi-Fi connection to reload. Okay, let me get that. I'm going to get that Main Turnpike data uploaded for you.
I have to mess about with security and things to read all of these and write. I think my
One more time, what do you want me to say? Okay. Keep talking. And Shima, I'm not sure what's happening. Let me see. If I go to topic